This shape, as we learned, is not only the root of all mathematical proportion, light, the Platonic solids, but is also the source of every musical system in the universe, including systems both used and unknown to modern man. It is also the source of energy patterns and, well, everything. It all comes from the flower of life. I believe this is what is at the heart of what's forming every subatomic particle formation, and it probably goes at least a few levels deeper than what Garrett is showing us. Phi, also known as the golden ratio, or golden mean, is a very simple relationship. If you had a rod and were going to put a mark on it, only two places would mark the phi ratio, which is here or here. The length of A plus B is equal to the length of C. This ratio is 1.6180339 and continues on forever. If you multiply the length of C with phi, it will create the exact same image, only bigger. C and D is equal to E. This ratio could then span on forever, going smaller and smaller or bigger and bigger forever. This ratio is infinite. It has no beginning and no end. It is also believed that phi is the mathematical root of all other sequences. See, every mathematical sequence in existence needs a minimum of 3 numbers to figure out the sequence. Phi only needs 2. It is the only one. Similar to how the circle and square are the source of all shape, but we'll get to that later on. Let's move on to our next sequence, which is called Fibonacci. Now, the Fibonacci sequence is life's way of creating the golden mean. Allow me to explain. This sequence is continually made from adding the previous number to the current. 1 and 1 is 2, 2 and 1 is 3, 3 and 2 is 5, 5 and 3 is 8. You can see how it continues. Now, what most people don't know about Fibonacci is that it actually continually strives closer and closer to the phi ratio. By dividing the current number into the last, you can see this happening. 1 into 1 is 1. Well, that's not close at all. 2 into 1 is 2. This time it's over phi, but closer. 3 into 2 is 1.5, which is under, but closer still. 5 into 3 is 1.666. This time it's over, but even closer. Continuing with that, it's 1.6, and then 1.625, 1.615384, 1.619048, and so on. It continually oscillates over and under the phi ratio, never quite making it there, but continuing on closer and closer every time, until eventually you can't even tell the difference. Because phi is an infinite number, this sequence will go on forever. Let's look at some spirals in nature, another way that phi and Fibonacci can manifest. This is a nautilus shell. Many people will say it's phi, but it's really Fibonacci. See how when it's in its earliest form, it's crude, not smooth or anything? One look and you can tell that's not phi. But as it goes out farther and farther, it gets closer and closer to phi. It becomes a nearly perfect phi spiral by the time it's all the way out here. This also happens with sunflowers, pine cones, and many plants in nature. In many cases, such as the pine cones and sunflowers, it flows in a double spiral or more. This is how a polar graph usually looks, with 36 radial lines in 10-degree increments, representing the 360 degrees. Then, concentric circles are drawn, each with the same distance away as the last, creating 8 equal demarcations as the one before, counting the inside circle as 1. Think about what this represents too. It's a 2-dimensional drawing of a 3-dimensional sphere, one of the sacred forms, by projecting it onto a flat surface. This is also called a shadow form, and casting shadows is a sacred way to obtain information. Also, a polar graph has both straight, male lines, and circular, female lines, both male and female energies interacting at once. If you plot a golden mean spiral at 0 degrees on the polar graph, it will loop all the way around before hitting 0 again, exactly at the 8th circle. You'll find that this golden mean line crosses 5 specific places as it goes out. These places are where the female circular lines meet the male lines. It crosses at 120 degrees, 190 degrees, 240 degrees, 280 degrees, and then it jumps to 360, or back at 0, depending on how you look at it. What's interesting about this is that it creates both a binary and Fibonacci sequence. Looking at the radial increments from the center, it crosses at 1, 2, 3, 5, and 8. Well, that's Fibonacci, but it also crosses at 2, 4, and 8. Well, that's a binary sequence. We're going to look at the binary sequence in particular though, because what you find is very cool. If you draw lines from the outermost circles on the lines where the binary sequence was formed, you get this image. It is an equilateral triangle. If you continue the spiral outward, it would continue to hit these exact same places and continue to form larger equilateral triangles. Let's divert yet again to look at something very interesting. There was a man named Keith Critchlow who discovered something very important to understanding the geometry of music. First, he drew a straight line through an equilateral triangle, and then he measured from the middle of the center line and drew a straight line up to the top edge and back down to the bottom corner. Then he did the same, but passed through the center line of the top and back down again. He did this yet again on the other side. You can keep doing this on either side as well. By drawing this funny little form, he discovered something of great importance. He writes, continuing in this way, each successive proportion will be the harmonic mean between the previous proportion and the total length, and all of these proportions will be musically significant. 1/2 being the octave, 2/3 being the fifth, 4/5 being the major third, 8/9 being the major tone or step, and 16/17 being the half-tone or step. In other words, he discovered the geometries of music, or at least one aspect of them. Then he tried measuring it in a different way, starting at a different point of the center line. At 3/4, he found the measurements were 1/7, 1/4, 2/5, 4/7, 8/11, and 16/19. All of these numbers are musically significant. This is very interesting. It means that the harmonics of music are somehow related to the proportions of the central line moving through a tetrahedron. Back to the polar graph, you can see that this drawing has a much greater value all of a sudden. Not only that, but it becomes even easier to make your measurements thanks to the polar graph itself. You can just draw a straight line through the drawing on the graph, and it will give you the center line. This information has been taken light years beyond what I just showed you though. A research team found that you can draw these lines not only from the center, but from any nodal points inside the upper half of the triangle, and you'll come up with all known harmonics in existence. Basically, this means that anywhere the straight line and curved lines on the polar graph cross from 0 to 120 degrees and start making the pattern, you will come up with all known harmonic systems. Not only the Western keyboard, but the Eastern, and even many unknown systems that have never been used. As I'm not a musician, there's not much more I can show you related to this, but I would love to see what a musician could really do with this knowledge. Remember when we talked about spirals in nature? They often travel in twos. Usually this is male and female. So on this polar graph, if you're going to copy nature, you don't just plot one spiral, you have to plot two. When you do that, it gives you this image, which is a star tetrahedron inside of a sphere. We mentioned this in lesson 7, and this image is more commonly known as the Star of David. Inside the star tetrahedron, another one fits perfectly. We can continue to put more and more star tetrahedrons inside or outside of the other star tetrahedrons, the same way the golden mean spiral can wrap around the polar graph infinitely big or infinitely small. You'll notice that this smaller tetrahedron also happens to fit perfectly around this sphere. Well, check this out. If you put this same size sphere centered on the point of every single star tetrahedral point, guess what suddenly reveals itself? What this means is that all of the information of music, harmonics, sound, and spirals come out of this image. Not only that, but light and the dimensional levels work in the same way as harmonics, which we've already discussed in lesson 2, 7, and 9. Meaning that the geometric information about light and dimensions are also related to this star tetrahedron pattern. So what you just saw was the second unraveling from the third rotational pattern of Genesis, the geometry at the heart of creation.
Well, from macro to micro, as I've shown you underneath the ferrocell, do you actually see this pattern? It's the same pattern you actually see on the sunflower. It's the exact same pattern that you see underneath the ferrocell, showing magnetic reciprocation occurring at the golden angle of 137.5077 degrees. The golden ratio is also the golden angle. This is just a simplex pine cone. So from the absolute most simplex fundamental principle of the entire universe, magnetic reciprocation occurring at the golden angle, this is the exact same pattern you see underneath the ferrocell, from macro to micro, from the scale of smaller than nano to the scale of galaxies, everything occurs at a golden ratio. Why is that? Simplex divergence and convergence. Reciprocating precessional hyperboloid, lowest extrapolation of simplex pressure mediation. It's also applicable to growth. This is applicable to magnetic fields. This is applicable to anything. Everything in nature at the most simplex and fundamental levels, be it growth or magnetic reciprocation, follows the golden ratio.